But it only means it only means one thing, that we need to make sure that you need to make sure that you push a lot in maths. Yeah, but I will give you the hint how to score 60 to 70 marks. I'll show you how. Okay, proceeding here, we have our angle A01 is equals to angle C1, and C1 is equals to angle A. So because we're interested in this one, we are going to say angle O1 is equals to 2C1. Is that correct?
Yes.
Okay. Then we can say the same again about angle O2, or we say similarly about angle O2. It's still the same
Yes.
statement, isn't it?
Yes.
Similarly, what do you say? Angle O2 is equals to 2 angle C2. Is that correct?
Yes.
Okay. Therefore, what does this mean about angle O? Therefore, angle O as a whole now,
Yes.
angle O, which is equals to angle O is equals to what? Angle O1 plus angle
Oh,
O2. This is equals to 2C1 plus
uh,
2C2. Is that correct?
yes.
Taking out the highest common factor, C1 plus C2. Is this correct?
Yes.
Okay. Then what is C1 plus C2? That is ACP. Is that correct?
Yes. Yes.
Hence, angle O is equals to 2 open bracket or 2 ACP. 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 Which is what you wanted to prove. Is that correct?
Yes.
Mhm. Was it difficult?
No.
Okay. The issue, the key part is on the construction. So the construction gives you 1 mark. The key part is on the construction.
Yes.
Construction gives you 1 mark, and then the rest is going to give you 4 marks. Now we are done with 8.1. Let's go to 8.2, I believe. We are going to 8.2. Let's read the 8.2.
Um. O is the O is the center of the circle in the diagram. BP is produced to M such that OM is perpendicular to AC. AC intersects OM at L. DS is the tangent to the circle at D. MBS, which is angle B, is equal to 45.
Okay, some hint here. When they say center, O is the center of the circle, they don't talk about tangent. It only means that we need to remember, or we need to take note of theorem 1, 2, 3. Line from
Okay.
the center bisect, line from the center perpendicular to the chord bisect the
And then
chord. Line from the center perpendicular to the chord bisect the chord.
I set the part.
That's
Okay.
theorem 1. Theorem 2, angle at the center is 2 times the angle at the circumference, which is what we just proven there. Then theorem
Yes.
3, angle subtended by semicircle, subtended angle in a semicircle is equal to 90 degrees, or an angle
90 degrees.
subtended by a diameter is equals to 90 degrees. Is that okay?
Yes.
Which is one of these? Where are you? Here. Here. That is 90.
Mm.
Because it's subtended by a diameter AB.
Yes.
Okay. Now let's try to answer the questions, I believe. And also, do you have a tangent? Yes, we have a
Yes.
tangent. So radi perpendicular
PS
to tan, yes. Radi perpendicular to tan, this angle, all of it is
90
90
degrees.
degrees. Then we have a tangent, it means theorem what? Theorem 789. 789. Let's look at tan chord.
Okay.
Let's look at tan chord. Do you
Yes.
see? This is a right
Yes.
perpendicular to tan. Let's look at tan chord, which is theorem what? Theorem 789. Theorem 9. Tan chord. Look at it.
Mm.
Do you see it?
Yes.
That is theorem 9. This angle 35. This one, you see?
Yes.
Tan chord theorem. And then this one, it's 90. Do we have theorem 8? No. Theorem 8 is the I, do you know that? The I, tangent from the same point. We don't have it.
Same point. Or yes,
Yeah,
we don't.
we don't have. So do you see the tangent there tells me that, oh, I need to remember theorem what? 7, 8,
Theorem
9.
7, 8, 9.
Yes, one of them will fall there. Center is telling me that, oh, theorem 1, 2, 3. It's possible in this case.
Yes.
Okay. Then when they say quadrilateral, cyclic quad, they are telling me that theorem 4, 5, 6 is possible here. So,
Okay.
so you can look for a bow tie here, you won't find it because they didn't talk about cyclic quad.
Yes.
Yeah, okay,
Yes.
it's fine. So it means then these words, they're telling us the answer. Now let's go to the question. Calculate with reasons the size of angle A1. We already got it, eh?
Yes.
A1 is equal to what?
35,
It's equal to
35 degrees.
35,
35 degrees.
35 degrees. Thank you. And then what is the reason?
Tan chord theorem.
Tan chord theorem. Thank you. Tan chord. Thank you. Then we are happy now. This is 35. Please do this to make sure that you don't lose marks unnecessary. Write it 35 degrees. So on that question paper of yours, when you are busy practicing, when you are writing the exam, please make sure that when you leave that exam room, the question paper is stated. Okay. Hello?
Yes.
Okay. 35
I'm
degrees.
here.
Okay. 35 degrees. So I was saying that make sure as you leave the exam, the paper, it's indicating that someone was writing. Tan chord. And then let's go to O3. O3.
Mm,
Look at O3.
90
O3, it's 90. Why?
angles and a straight line.
Angles on a straight line. What about O2?
Ah, we also have O2. Um, yeah, but it's 90.
No, it's not 90.
No, it's not 90.
Mm-hmm.
Um,
We are in theorem what? Remember theorem? 1,
oh,
2.
angles subtended by same chord.
Okay, so angle O3 is equal to what?
35.
No, they are not equal. We just did it now. Angle at the center is 2 times the angle at the
Oh, angle
circumference.
at the circumference.
Yes, so let me show you that symbol if you forgot it here. Remember I said,
Oh,
do you remember I said when they say center, so this angle and this angle. So this one is 2 times this one
yes.
because this one is at the center. They are not equal. So O3 is equal to 70 degrees. What is the reason?
Mm,
Angle at
angle
center
center.
is equals to 2 times angle
Angle
at
at the
circumference. Is that okay?
yes.
So this is some good news there. Then P3. So remember I said when you get it, write it down.
Yes.
It will help you. It will save you. So we're looking for P3. P3 is also 2 marks, meaning it's a statement and a reason.
Yes.
Mm-hmm.
P3.
P3.
Oh, P3. Yeah. And we have 70 here.
Mm-hmm.
Don't say yet. I'm still checking.
Okay.
We don't have parallel lines.
Now, remember, what did we talk about? Center and tangent, eh?
Yes.
Did they say parallel?
No.
But what did they say? BP is produced to M
BP is produced
such that OM is perpendicular to AB. Oh, they are referring to this angle, so we saw it. Okay, it's fine.
Yes.
Are you tired now?
Head.
Like, are we tired of checking?
No, we're still checking. We're still checking.
Okay. P3.
Alright. We cannot say the exterior angle.
Exterior angle of what?
Triangle OAP.
OAP. You still need O2 before you use that.
Oh.
Can I intervene?
Yes, unfortunately.
Okay. Don't forget the radius. The radius are equal.
Yes.
Do you see?
Yes.
This now becomes isosceles triangle. Do you see that? Hmm? Is it
Yes.
visible or not visible?
It's visible.
It's visible that it's an isosceles triangle now.
Yes.
So this
Yes.
is what we can say now. We can say okay, P3 is equals to 180. Can we say P3? Yeah, let's go. Angle P3 is equals to angle P3, or can I say 2P3? Yeah, let me say 2P3. Let me divide by 2. Let me divide by 2. Okay, it's fine. 2P3. Do you understand when I say 2P3? Why?
Yes, so that
Angle
you
B,
can get
angle,
angle P3 and angle B.
they are equal, ne? So
Yes.
2P3 is equals to 180 degrees minus 70 degrees. And
Which is
then
110.
110. And then our reasoning will be here. Our reasoning will be what? Sum of interior angles of
Other type.
of a triangle. Therefore, P3 is equals to 55 degrees. Is that correct?
Yes.
Dividing by 2. So there is your 2 marks. 1, 2. After you get it, you write it down. You won't regret. 55 degrees. 55 degrees. Okay. Now let's go for 3 marks. They're looking for M1. M1. For 3 marks, they are looking for M1. For 3 marks, they are looking for M1. For 3 marks, they are looking for M1.
Let's see.
Any idea?
We must try to find, if I'm not mistaken, we must try to find angle Q2, and then we can add Q3 and Q2 and
Did you
angle
say
B,
Q
and then
or
minus that.
O2? Did you say Q or O2?
It's O, sorry, O2.
We must find O2 first, Danny.
Yes.
Okay, that was very good of you. So, what can we say here on this question? That was very good of you. That's very good. Okay, very good start. Let's go. So we are looking for O2. I will highlight it later. Let's go. Angle what? BOM.
Yes.
BOM is equals to what? 90 degrees. 90 degrees. 180 minus 90.
90.
Then angles in a straight line.
Why we we're only including the O3 and O2, ne? We're
Yes.
excluding OY.
Yes.
Oh,
BOM is equals to 90 degrees angles
90 degrees.
in STR line. Okay, therefore angle O2 is equals to 20 degrees. What can we say here? Yes, is it complementary or supplementary angles?
Supplementary.
No, they are complementary. Or we can still say angles in a straight line. Angles
English simple.
Angles in a straight line, eh?
Yes.
Okay. Then we have O2 is equals to 20 degrees. We write it there. Then we remove almost every line. We come back to what we want. Are you looking?
Yes.
Are you looking? Are you looking? Are you looking? Do you see the exterior angle?
Where?
Yes. Do you see the exterior angle?
Can you show me one more time?
Can you see this is 20, eh?
Yes.
This is 55. This is M1. So as far as things as we know, this angle plus this angle is equal to that one. Is that correct?
It's equal to 55. Yes.
Yes. So therefore we say hence angle M1 is equals to 55 degrees minus 20 degrees. Then we say exterior angle of a triangle. Is that correct?
Yes.
Angle of a triangle. Okay. Winning so far so good?
Yes.
35. Wow. Did I see that? Oh. Oh. Hey. Did you see this? Look. This is
Right.
35. This is 35.
And that one is 35.
Which one? And this one is 35.
Yes.
Do you see a bow tie here?
Yes, I do.
So I'm like,
OPAM.
yes. So I think now they are going to say,
So it might be a cyclic quad.
thank you. You just conclude.
Prove that OLP is a cyclic quad. It is a quadrilateral. Cyclic quadrilateral. Yeah.
They're saying prove that OLPB. OLP.
Yes.
They run away now. They're no longer coming back here.
Mm.
Okay, it's fine. We'll see how. Okay, prove that OLPB is a cyclic quad. So OLPB is a cyclic quad. So what we do here usually, that's what we must do. This is what we must do. OLPB is a cyclic quad. This is what I do usually. Let me remove this, remove this, remove this. Okay, maybe I will need you. Then this is what I do. I don't know what is it that they've taught you there at school, but this is what I will do first. OLPB. So let's see. This is 55.
Mm.
And then if it's a cyclic quad, what will it mean? Any idea?
The opposite side must add up to one.
I'm listening.
Opposite interior sides must add up to 180.
Opposite interior angles, not side. They must add up to
Angles 180.
180. Okay.
And then the exterior angle is equal to the opposite interior angle.
Okay. 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 No, I do agree with you that angle B must be plus angle L2. Is that what we are saying?
Yes.
Okay. That's good. But this is just 3 marks. Why must we suffer that long? Okay. Can we look at the shape that we are looking at now, which is this is our quadrilateral. Do you see that?
Yes.
Okay. So if you look, this one it becomes our exterior angle of a cyclic
Yes.
quad, and this is opposite to this.
Yes.
So what if this one is equal to this one? And the question will be how?
How?
Let's see, APB. Let's look at APB. It's subtended by a diameter PB.
Yes.
Then it means APB is 90. If APB
Oh
is
yeah,
90,
and
yeah. Do you
it
see
means
the
O1 is 90. Yes.
and O1 it's 90. Therefore, we are done. So let's
Mm.
go. Step number 1. APB is equals to 90 degrees. Then what we say, angle subtended by a what? A diameter or angle in a semicircle.
Angle yes.
In a semicircle. So we are happy there. And O1 is equals to 90 degrees, which is given. It's indicated. Is that correct?
Yes.
So we have used theorem 5 here. Is that correct?
Yes.
APP and O1 are equal. Therefore, we conclude that, what did you say? OLPP is a cyclic quad. OLPP, we conclude now, there is our 3 marks. OLPP is a cyclic quad. Give us a reason. Exterior angle of a cyclic quad equal to the opposite interior angle of a cyclic quad. Very long reason.
Yes.
Then we get our 3 marks here.
Nice.
We are moving.
Yes.
So here is my story. So here is my story. If you prove that this is 90, so this one it means it's 35, right? Okay. 35. Then keep the circle. You see how dirty it becomes now. Keep the circle.
Yes.
Before you jump to the next question. Prove that BS is parallel to OM. BS is parallel to OM. Prove that BS is parallel to OM. BS. Let's get BS. BS parallel to OM. True or false?
True or false?
BS parallel to OM. It's pretty obvious.
Wait. Let me see something.
Can I remove the nyaga nyaga?
No, don't remove it yet. Something.
Okay.
Yeah, we can talk about this angle O2, O3 and O2, and then we can talk about the whole of angle P. You see that 55 and the 35.
35 and 35. Which one and which one?
The 55 and the 35.
55 and 35. They're adding together give us 90.
Yes, and then 70 and 20, they give us 90.
70 and 20.
And then when we add them, O3 and O2.
But what are we talking about here? Which line are we talking about?
Line.
Which line and which line?
OM and BS.
So how do we prove that how do we prove that they are parallel?
Maybe we can say that angle B and angle O3 and O2 are co-interior. Yes, co-interior.
So angle B. Okay. Angle B and angle O3, they are supplementary.
Angle O3 plus O2. Actually, when you add O3 and O2, they add up to 90.
And then angle B is equals
and
to
then
what?
That 55 plus 85.
It's what?
It's 90 as well.
Okay. Do you see why I said don't remove those writings?
Yes.
They save you. They save you. Okay. Angle B plus angle O2 plus O3 is equals to 180 degrees. Is that correct?
Yes.
It's equals to 180 degrees. Therefore, BS is parallel to OM. Give us a reason. Co-interior angles are
Angles.
supplementary.
Supplementary.
Co-interior angles are supplementary. Or we could have said the one that I thought you were going to bring. 90 degrees here.
Mm.
I'm looking at this slide, so you need to highlight them.
Okay.
90 degrees here and 90 degrees there. Corresponding. Corresponding.
Oh, the letter F.
Yeah.
Corresponding, yeah.
Yes. So this is how we're going to write it. So which one should we write? You choose one. Should we write yours or
Let's
mine?
not type both.
Okay, it's fine. We are going to
Example
say
fully.
angle B plus angle O2 plus O3. This is equals to, you show substitution. Don't give it a reason, just do substitution. This is equals to 90 degrees for angle B plus 20 degrees plus 70 degrees plus 70 degrees. This is equals to 180 degrees. Okay. Therefore, BS is parallel to OM. Give us a reason.
Co-interior angles are supplementary.
Co-interior angles are supplementary. Are supplementary. Are supplementary. Okay, it's fine. Then we are done. There we get our how many marks? 2 marks.
2 marks.
Then we can also write it in this way, or what can we say? Or angle B is equals to 90 degrees. Angle B is equals to 90 degrees. Maybe the reason will be proven.
Yes.
Okay, and then O1 is equals to 90 degrees. Then the reason will be given. Therefore, angle B is equals to angle O1, hence BS is parallel to OM. Reason corresponding angles equal.
Corresponding angles.
Angles equal. Corresponding angles equal. Okay.
Yes.
I
Are you sure it's recording?
Hello.
Are you sure it's recording?
Yes, it's recording. Why?
No, I just want to be sure.
No, it's recording. It's recording. I with someone there.
No, I'm alone.
Oh. No, it's fine. You can watch with someone. Just I heard a voice. I thought maybe you're with someone.
My siblings are moving up and down.
Oh. You can bring others. It's fine. As long as you are happy to pay alone.
My neighbors have a very good. No, they're not really neighbors, but they have a good list.
Mm.
They always get a distinction.
No, that's nice. That's nice. OP is a tangent to the circle through. Prove that
PLAM.
OP is a tangent through to the is a OP is a tangent to the circle through PLM. A circle that passes through PLM. Huh. Show that OP is a tangent to the circle that passes through PLM.
It only touches the
Okay, so the circle.
circle P.
Yes, so it's fine. Let's have this circle. Let's remove this one. PLM. Yeah, I believe this question paper was it easy.
Yes.
Yeah. So if OP is a tangent through the circle that passes through PLM, this is OP. Where is OP? Let's try to remove almost everything here. It's fine. We will bring you back. M1, we need you. M1, it's 35. Is that correct?
55. Yes.
And then this is OP that we're talking about. Is that correct?
Yes.
And this circle and this angle is also 35. Is that correct?
5. Yes.
You see when I say let that paper be dirty. So
Yes.
if OP is a tangent, it means we need to see something that is tan chord theorem. Do we have it?
P. P3. That's P3, ne?
P2.
No, it's P2. Oh, yeah, it's 35.
P2 is the same as M1. Is that correct?
M1. Yes.
Then that is tan chord theorem. Is that correct?
Yes.
Then that means OP is a tangent.
Yes.
But do you see that whatsoever that I'm doing here, it's very much necessary.
Yes, sir.
I think without these drawings, things were not going to be that easy. So P2 is equals to M1. Therefore, what does it mean? It means therefore LP it's a tangent. Is that correct?
Yes.
Let's see how many marks are there. 3 marks. Okay. Where? So angle P2 is equals to angle M1, which is equals to 9, which is equals 35 degrees. Is that correct?
35.
35
Yes.
degrees. What can we say here? Is it proven?
What happens when you say that statement? Yeah, convex.
Let's see here. What we have here. Looking here at this angle, why are we saying they are equal? Mm, mm, yeah, I think we can use the converse.
Okay.
Converse of what?
Telecode.
Converse of Tankot theorem. Converse of Tankot theorem. Therefore, what can we say? Is that OP? OP is
Yes.
OP is a tangent.
The tangent.
OP is a tangent. I think this converse of Tankot theorem was supposed to be used in the final. Here we're supposed to say maybe proven here.
Oh.
Yeah. So OP is a tangent. And then the reason will be this one. Converse of Tankot theorem. And then here on top of it's supposed to say proven.
Okay.
Because that's what we have proved, that M1 is equals to 35. We also proved that P2 is 35. So it means it's proven that they are equal.
Okay.
That was our last question on question 8. Hey, 22 marks.
322 marks. Wow.
Was it free?
Oh, it was not too bad.
Okay, no, that's nice. Let's go to the next question, which will be our last one, and then more work for you. I'm hoping that on our next lesson we can talk about what which topic.
Let's say trick.
Going back to trick. No, it's fine. It's fine. Fantastic.
Addition.
It also has more marks. It's fine. Let's see the question 9 in there.
In the diagram, is DE a tangent to the circle at P? EFG is a straight line. DE is equals to FG, which is equal to DF. HF is parallel to DE. It is further given that DF over DE is equal to Y. Let DEF, which is angle E, equals to X.
Mm-hmm. Okay. Give with reasons 3 other angles equal to x.
Let's see.
Give me the first one.
I'm still checking. Angle angle is it D? D.
Did you say D?
D.
E.
G.
G.
Yes.
Yes.
And then
Why are you saying angle G?
tan cot theorem.
Angle G is equals to X. Then we're going to say tan cot theorem. So G is equals to X. So please, before we move,
indicate.
Yes. Then the next one.
And then angle E2.
E what?
2.
E2. E2 is equals to what?
Then I said X.
X, and then will give us a reason.
Angles opposite equal.
Angles opposite equal side.
Is it right?
Yes, that's correct, because you see here.
Okay.
Yeah, so
And then remove. Indicate.
yes, indicate before you move.
Angle F2.
Angle F2.
Is
Give me a reason.
alternating angles.
Yay, you are doing well, eh? F2 is equals to X alt angles equal comma FH. FH
E.
is parallel to what?
DE.
DE.
Is
Okay. Very well. Wow. 6 marks. You took all of it. I thought you're going to miss one. Okay, X. Now prove that EH over HG is equals to Y. Where is Y? It is further given that DF over DE is equals to Y. DF over DE is equals to Y. So prove that EH over HG is equals to what?
Yes.
Is equals to Y. Any idea? This is grade 12 now. We're done with grade 11 and senior fish.
Maybe we can use proportionality.
Maybe we can use what?
The proportionality theorem.
Yes, that's what we're getting into. That's grade 12 now. Let's go. Let's check here. EH over HG is the same as what? As DF
F
over
over
what?
DE.
Over.
DE.
Wait. Let's go step by step. EH over HG is the
Yes.
same as DF over what?
Over DE.
No, FG.
Hmm,
And
FG.
we have parallel lines here.
Oh, I thought we were using the statement that's on the top.
No, 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 no. We are doing the proportionality. You know proportionality theorem, eh?
Yes.
9.2.1. Let's go. Step number
Okay.
1, EH
Yes.
over what?
Over HG.
HG
Yes.
is the same as what?
F.
DF, eh?
Yes.
Over what? FG.
FG.
So we can say line parallel one side of a triangle as a reason, or we can simply say FH parallel DE. Which one do you prefer?
What H parallel DE?
Okay, you will remember that.
Yes.
FH parallel DE. Okay, now let's look at D. Let's look at what? Oh, do we have a line here? Yes, we have a line. There it is.
With
Let's look at DE and FG. DE and FG. Do you see that they're equal?
yes.
A
DE and FG. Yes, I can see.
with that stripe. Do you see that, Danny? So
Yes.
if we come back here, this will mean that this is DF. Is that correct?
Yes. Yes.
Nothing we can change. But FG can be written as DE. Is that correct?
Yes, because they're equal.
Since what FG is equals to DE,
Yes.
and this is given. It's not from us, not from any
Yes.
theorem. So let's go. DF over DE is equals to what? Y.
Y.
You know what is amazing about proportionality theorem?
But
It's so simple. Yet people, they are so afraid of it. So do you see that? EH over HG, straightforward, isn't it?
yes.
Okay. Does it make sense?
Yes, it does.
Okay. Now prove that angle D is equals to 72. Angle D is equals to 72. So let's see here. Do we have any angle there? No, we don't have. So, but we are looking for angle D, isn't
Yes.
Okay. So, looking at angle D, what do you think?
D is close to angle F plus F3 minus Yeah.
Come again, you're saying angle D
Is equals to angle F2 plus F3 minus angle X minus X.
angle D is equals to F2
Yes, plus F3
plus F3
minus angle E.
minus angle
I
E.
think it's E1, yes.
Okay, that's exterior angle of a triangle.
Yes.
Mm, looking at this one, let's see here, we have parallel lines. We have parallel lines. And then DE is equals to EF. Oh, do you see that?
Yes.
DE is equals to EF. There is a stripe.
Yes.
So meaning therefore angle D and F1 are equal.
Equal. Yes.
So what will it mean about angle D? We can simply say, I wanna move. Or let me, can I remove this?
Yes.
Okay. The old man doesn't want to retire.
Which old man? You.
Zuma.
Oh.
So we can say angle D is equals to, remember, D and F1 are equal. Is that correct?
Yes, angles opposite equal sides.
Yes. So I think maybe we can start by stating in triangular DEF,
Yes.
in triangular DEF, angle D is equals to 180 degrees minus X, which is that one. Then we divide by 2 because there are two D's here. Ne?
Yes.
Then we say angles in a triangle.
Yes.
Angles in a triangle. So angles in a triangle.
Yes.
Then what do you think?
Angle D equals to 90 minus X over.
What do you think? What will be the next step? We are stuck here.
And maybe we can say angle D is equals to 90 minus X over 2.
Well, or X over 2, but it's still the same thing.
Yes?
It's the same thing.
Alright, let's think of something.
Okay, let's go back to the diagram. So we have dealt with this one, with this triangle. Is that correct?
Yes.
We have dealt with this triangle. So we've dealt with this one. Then this one give us this 90 minus 2 x over 2.
X over 2.
The one that you are saying, x over 2.
Yes.
But if we were to expand our triangle, I do have this angle, have that angle, I have that angle. Can I win?
Well, they're all equal.
No, this is 2x, this is x.
Oh.
Do you see that?
Yes.
So I will say in triangular DEG, triangular DEG,
Yes.
angle D is equals to 180 degrees minus what? This is 2x,
X, and then this is X.
minus 2x minus x. Still the same angles in a triangle. Is that correct?
Yes.
Then this is equals to, or therefore, what is DEG? DEG, I can, angle D. Angle D is 180 degrees minus x over 2. Then this is going to be 180 degrees minus 3x. Is that correct?
Yes.
Then maybe we can start solving for x. 180 degrees minus x is equals to 2 times 180, which is 360 degrees, minus 2 times 3, which is 6x. Is this correct?
Yes.
Therefore, what I'm looking at now, I'm looking at 5x. Is this correct, 5x?
Yes.
Negative x plus 6x is 5x, honey. Then
Yes.
360 minus 180, the answer is 180 degrees. Then x is equals to what?
80. 36.
36. That's correct. Therefore, we go to D. Hence, angle D is equals to 180 degrees minus x, which is 36 degrees. Is that correct? Divide
Yes.
by 2. What do you get?
72.
Is this what we're looking for?
Yes.
Okay. Happy? Are you happy?
Yes.
Okay, now we need to place back these angles
Okay.
to make our life easy before we move forward. So, this was x, eh?
Yes.
So this is 36. This is also 36. This is also 36. This is also 36.
36.
This is 72.
Yes.
This is 72. This is also 72.
Yes.
Okay, making our life very much easy for sure for the next question. 9.2.3, I refer to this one as the simplest of them all, similarity.
Okay.
Prove that triangular what
DGE.
DGE is a what?
Similar to triangle DEF.
Yes, similar to triangular DEF. So let's go. Let's go. Remove.
What?
Can I remove?
Yes.
Or let me try to write here. I don't think I'll finish. Let me try to write this side. Let me come back to my side. Okay. What do we have? What do we have there? In triangular DGE and triangular what DEF and triangular DEF. Let's look at these two triangles.
Line.
DEG or DGE.
Yes.
DGE. So the bigger one, let's close it. DEF.
The smaller one.
The smaller one. Proving that they are similar, I think this can be very much straightforward. It's not straightforward.
We'll see. I'm not really familiar with this question 9.
Okay. So look what I'm going to do. We usually call it the eye. So
Okay.
let's go. Look at D and D. D and D, it's common. Do you see that?
Yes.
So D and D is common. D is common in both triangles. Do you see that?
Yes.
The black one and the red one, they meet at D.
Okay.
So we'll say D, angle D is equals to angle D. Say common. Okay.
All right. Yes.
Now we are done with this one. Now we move to G. Let's look at G.
Yes.
G goes with which one?
E.
E. You see G and E, they are connecting.
Yes.
Okay, can I call this one E1?
Okay.
Yeah, I'll call this one E1. And then I would say angle E. No, you start with G. The one on this
Yes.
side. On this side. It's very straightforward. You just take it there. Angle G. All that you do, you just go to the diagram and try to check how are they equal. Angle G is equals to angle E1. And then it was proven. We proved it in number 1 there.
Yes.
Proven. And then we move to the last one, E and F.
Yes.
Which one? Which E are we talking about now? They're talking about the bigger E.
Yes.
Yes, the bigger E and F1. So on this one, what can you say? Yes, you can say they're equal 72. As you can see, 36 plus 36 plus this one is 72. Do you see that?
72. Yes.
Yes. But in most cases, just for argument's sake, angle E, okay, which is the bigger on the whole E, is equals to angle F1.
Yes.
Then you can say, since you've proven these two, say third angle.
Okay.
Third angle of a triangle.
Okay.
Is that simple?
Yes.
Therefore, triangular DGE is similar to triangular DEF. Then what was
Yes.
how did you prove this one? Angle, angle, angle,
Angle.
angle, angle, angle.
Yes.
Was this difficult?
No.
Angle, angle, angle. Okay, now that we have proven something that was very obvious to us, we move to the next question. Let's look here. This is our another conclusion.
Yes.
This is another conclusion of similarity. If I can just put it straight for you. This is the second conclusion of similarity, if you remember senior phase. So let me show you how. So what we're going to do here, let's look here. Look, let me show you how. Second conclusion, I'm going to do it here. I'm going to do it here. Look, I'll say to answer this one, I would say DG. Do you see DG?
Yes.
I'm just taking it from here.
Okay.
DG, if you remember what we did in grade 9, when you do proportionality, DG over DE. Do you see that?
Yes.
Is equals to GE. So I took the first two, now I'm taking the second two. It's equals to GE
over EF.
over EF. What is left?
E and
The last two, the
D
I,
E.
DE
Yes.
and DF.
EF. Yes.
DE over DF. Please give us a reason. Your reason, it can be this is proven here, or you can say what? Triangular DGE. Triangular DGE is similar to triangular DEF. Exactly
Yes.
that. Do you see that? So
Okay.
now you come back now to this thing. What do we need? We need double E. Double
Okay.
E. We need double E. Do you see double E? Do we have GE? Do we have GE here? Do you see
Yes.
GE? Here,
No.
there is no
No.
GE. So it means this one is out.
Yes.
Then you go and say DG over DE is equals to DE over DF. Difficult?
Yes. No.
Then we do cross multiplication. DE times DE, that's DE squared, isn't it?
Right, yes.
Which is equals to DF times DG.
Yes.
Was this difficult?
No.
Okay. So the issue here, Paulo, is to be able to see that, oh, after I prove similarity and they ask me this, it means this is the conclusion from this one.
Okay.
Okay. Now, let's go to 9.2.5.
Okay.
9.2.5. Let's see, what do they have here? They are saying y squared plus y is equals to 1. I won't lie to you. This one is very hard.
Okay.
Yeah, this one is very hard, but let's try. Let's try. Let's not forget the value of y that we were told.
DE over DF. Or DF over DE.
df over de is equals to y.
Yes.
And then we also prove that EH over HG is y.
Yes.
Okay. And then DE over DF
DE.
over DF.
DE over DF.
Here, it's DE over DF. Here,
Yes.
we're trying to connect y. So
Oh, okay.
DE over DF. Let's go back. DF over DE is y. Is that correct?
Yes.
Can I remove this?
Yes.
Okay. Trying to go back now. Yo. Well, we saw y, so our hint here was y. So that's why we say, okay, this DF over DE is y. It's y. Can I say it's y over 1?
Yes, you can.
Okay. Then it comes back to say to us 9 point what?
2.5.
9.2.5. 2.5. It comes back to say to us DE over DF over DF, which is equals to DG over DE, which is equals to DG over DE,
Okay.
which is equals to DG over DE, which is equals
Yes.
to DG over DE. So let's look at DE over DF. DE over DF, it's 1 over y. Is that correct?
Yes.
We striped it since that one it's DF over DE.
Over DE.
Okay.
Yes.
Now let's go back to DG and check. We can see DE. DE, we have you here. We do have DE here. But let's look at DG.
DG.
DG. DG. Can you look at DG?
Yes.
DG is not the same as DF plus FG.
F. FG. It is because they are equal.
Not necessarily they're equal, but DG is made of DF plus FG.
Oh, plus FG, yes.
Yes. So this can give us a hint. Let's go. DF plus FG over DE. Is that correct?
Yes.
So why are we trying to do this? We are trying to connect this DF and DE.
Okay.
Do you see what we are trying to do here? We're trying to connect this DF and DE.
DF and DE.
So 1 over Y. 1 over Y. Let's see here. This can be written as DF over DE. Is that correct?
DE. Yes.
Plus
Plus
FG
F over DE.
over DE.
Yes.
1 over Y is equals to DF over DE is Y, ne?
Yes.
Okay. So I have my Y here. I think this page must come down here. Please come down. We've been writing for long, so
Yes.
no wonder it's freezing now. But we are done, eh?
Yes, only one question left.
It's nice thing that we are still winning. So far, so good. Please come down. Oh. Okay, please. Are you really freezing on me? No, it is recording.
Okay.
Yeah. Okay, it's fine. I'm going to leave you alone. Ah, you have moved. You didn't know. Okay.
Okay.
Okay. We want you to move a little bit up. So FG over DE, let's see, FG over DE
FG
over DE.
they are equal.
FG and DE are equal. Ah,
Yeah.
okay. This thing is still pro. So FG and DE are equal.
Yes.
Okay, so this is good news. So it means this is plus DE over DE. Is that correct?
Yes.
Over DE. You're freezing now. Don't. We are almost done. I'm going to leave you alone. 1 over Y is equals to Y plus 1.
Yes.
Yay! We are winning. Cross multiply now.
Yay.
Ne?
Yes.
1 is equals to Y squared plus Y.
Y.
Wow. What is that we wanted to prove?
That 1 is equals to y squared plus 1.
Exactly this.
Yes.
Oh, I didn't see that. I didn't see that coming. Oh, okay. So how did we connect this thing by wire, ne?
Yes.
Okay. So let's go to this last question. They're saying cos 72 degrees is equals to y over 2. So when I look at this, I'm looking at a trig ratio. I do have 72 degrees.
Yes.
When I'm looking at this, I'm looking at a trig ratio. Okay.
Yes.
How many marks? It's 3 marks. So how do we involve the y? So let's go to so let's look at this angle. This is 72, is that correct?
Yes.
It's 72 degrees.
And angle D.
And angle D is also 72 degrees. And this one is 32. But since we don't have a right angle triangle, we can't use the trig ratio. We can only use the cosine rule, sine rule, and area rule. Is that correct?
Yes.
So it means then we are going to go to triangular DEF. Triangular DEF. Let's go in triangular DEF.
Yes.
Triangular sorry. In triangular DEF. What is it that we have here? Triangular DEF, we focus in angle D, we can say, if we focus on angle D using the cosine rule, we can say that EF squared using the cosine rule.
Okay.
EF squared is equals to, we have EF squared is equals to what? DF squared.
DF squared.
DF squared
Plus
DE squared and
yes.
plus DE squared minus 2 times DF
DE
times DE cos D, ne?
Yes.
So this is looking at that cos 72. It means we need to make cos D subject of the formula, ne?
Yes.
So it's very straightforward. Therefore, cos D is equals to, let's look, this one will go this side be minus, this one go that will be minus, but we're going to divide by a negative,
Yes.
so making this one to be positive, making this one to be negative.
Negative.
So it's going to be df squared plus de squared minus ef squared. Is that correct?
Yes.
Over what? 2
Over 2 DF
df multiplied by de, ne?
DE. Yes.
De. Okay. Are we winning so far so good?
Yes.
Okay. Now let's try to look at this friend of ours. How do you proceed from here?
We substitute, I think.
We substitute. What do we have for df?
Yes, we also have angle D.
You also have angle d.
Yes.
Okay. We also have angle d. Okay, it's fine. Angle d is 72, but my concern was here. DE, 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 EF. Let's come back here. Let's see. EF is the same as what as DE, and
Yes.
okay. That makes our life easy. EF is the same as DE.
Yes.
Aha. Now our life is easy now. So it means this is 0. Is that correct?
Yes.
DE is equals to EF, so this is 0.
They minus each other. So.
They minus each other. This is equals to DF squared over 2 DF multiplied by DE. Is that correct?
Yes.
That is cos D. This one is obvious. This is 72. We can write cos 72 degrees. But the square will cancel DF. Is that correct?
Yes.
Then we
1
have,
DF.
then we have DF over 2 DE.
Yes.
Aha. Are we not done? Cos 72 degrees is equals to, this is df over de,
Which is
1
1.
over y, eh?
Yes.
1 over y. Thank you. So this is going to be, we are done now, eh? Be patient. 1 over 2y,
Okay.
which is exactly what we're looking for.
What we're looking for. Yes.
Yes. You have done me well. You have done me well. Jesus.
Done.
Done. More work for you. More work for
Okay.
you. I will send on the group. Let me stop the recording.